Hey everybody, it's Mr. Herman again with another video. Here we are with the area of circles today and some more complex questions towards the bottom of this lesson. So it'll start off kind of basic, but then it gets a little harder towards the end. So those of you that haven't done this before, again, make sure you watch these closely. And you can always, I guess, rewind it or move it back and pause it and start it back over again. So this is a lesson for 32620. It's for Thursday, and that's going to be on areas of circles. So let's start by talking about the basics again. Like yesterday, the area this time is now not going to be talking about the distance around, but how many squares, actual exact squares it takes in miles, so miles squared, here it's meters squared, right, to actually fill this up. Now, it doesn't take too much to figure out that those squares are all going to get the edges cut off here. And they're not going to be whole squares on the outsides. Inside they might be, but not outside. So based on that, what we can say is that the squares are all going to be partial squares, and that's partly why your answer was always in decimal. We're going to round the nearest tenth for practice, so let's go nearest tenth. And we're also going to say that pi is, again, about 3.14. We're not going to use that long, crazy number in your calculator. So the formula for this is the area equals pi r squared. You have to have the radius for this one to do this. So unlike before where you didn't have to have the radius, this time you do have to have the radius. Yesterday you had to have the diameter. So let's try and take one here and figure this out. So the area equals pi r squared. And I'm going to put it down for each of these like that so we can have it ready to go. And then we'll substitute the numbers in for this problem. 3.14 is the pi. The radius is 12 because it's only half, that's right. 12 squared. Let's go ahead and use our calculator here now and type this in. So we're going to say 3.14 times, and you're going to need to hit the 12 and then the x squared button, which is right here. I'll show you. You can do 12 times 12 too, but it's x squared button's right here. That puts that little square in there then, see? Then you get it equals. So we get 452. That right there looks pretty good. 452, and again, it's about that. 452 point. It says 1/6. The 1/6 we're going to round to a 2, nearest tenth. That's going to be in miles squared. Remember, it's squared, of course, because it's squared in the formula. That's another way to remember it, too. Now, let's try this one over here. This one says the area is equal to pi again, of course, times the radius. This time the radius is not 6, right? We have to double, take half that. That's double the length we need. So we divide 6 by 2 to get 3. So 3 is what we need, so times 3 squared. Remember, 3 squared is not the same as 6. Only one that works with is 2. So now we're going to take and put it in as 3.14 times 3x squared, which is our squared button. That's going to be, then the area is about 28 point, nope, I'm going to say 3, aren't I? 26, that's 6, rounds it up to a 3, it's more than 5. So 0.3, and that's going to be in meters squared. There's our answer for that one. Now let's try another one where we're not given the circle again, but we have the amount told to us, which is just to find the area. We just know the radius. So let's try this one out. So the area formula, always start with that formula first. I was pushing this in a lot of the classes towards the end, but everybody didn't get to this. So those who didn't get to it yet, still need to kind of follow along and see how this works. I always start the formula because sometimes I'm not going to give you the radius. I'm going to give you the area and have you find the radius. So it's not always the same. You'll see in a minute. So let's start with the area here, and it's going to be 3.14. The radius is 12. Which I think we just did above, didn't we? I didn't realize it's the same problem. I'm sorry about that. Why don't we change that for the heck of it? Let's just make that 14 feet. Because really it doesn't make sense to do the same problem we just did above. So we'll make it 14 feet. And that's 14 squared. Using our handy-dandy 30x2s here. We got 3.14. Try to squeeze this in so you can see it. 3.14 times 14x squared. That's going to be 615.4. The 4 does not round up right there. So 615. And again, I say about because it's not really the same amount. 615.4 feet squared. And remember, it's about for two reasons. It's about because we rounded it, and it's about because we use the value for pi that's not exactly equal. Right? Now let's try a couple more. These are a little bit harder. Now we're going to be asked to find something else. We're going to be asked to find the diameter this time. And we're asked to find the diameter when we don't have the radius given or anything given, just area or circumference. So watch how these two work. And I realize I made a mistake here again. Boy, it's easy to make mistakes. Get rid of that square. That doesn't belong there. Sorry. So this one, again, start with the formula first. So the formula is area equals pi r squared, because it's the area they give you, okay? Then I'm going to substitute the area with this, 8 pi, because it says that's the area. So I'm going to put 8 pi right here. And then bring down the formula, pi r squared. And again, some of the classes have already been introduced to this and others have not been. So if you've already seen this, you might know what to do. If not, then definitely want to watch and slow it down and take time here. Now we're going to take and get rid of the pi's. Divide by pi on both sides. You're canceling it out. And now we have 8 equals r squared. Now to get the final answer, we have to take the square root of both sides. So the square root of both sides would be this symbol here. And you remember this from the other day. We did this with the Pythagorean theorem. So I'm just going to take 8 to the half power. Remember, that's kind of my shortcut. So 8 caret 0.5. And that's going to be 2.828. And we're on the nearest tenth still. Let's focus on the tenth. So I'm going to say it's 8.2. I'm sorry, it's 2.8. So it's just 2.8. So the radius is about 2.8 inches. Remember what it asks us to find? It wants the diameter. So to find the diameter, I'm going to have to take this and do what with it? Hopefully somebody's thinking in their heads there. You know? That's right. You have to double it, times 2. So take the 2.8 times 2, which is 5.6. Here we go, it's 5.6. And we get a diameter of about 5.6 inches. Okay, sorry about cutting that off there. Now let's try with the circumference formula. This one's a little bit easier, actually. So this is the harder one. I probably should have switched these around, but this is the tougher one with more steps. For the circumference formula, here on this one, it says the circumference is 124 pi inches. So we start with the circumference formula, because it gives us circumference. Circumference equals pi d. Then from here, we're going to substitute in. This is the circumference right here. So put it right here, 124 pi equals pi d. Bring that down. Then, what we do last time right here, we had 2 pi's there. You do what? That's right, divide by pi. That gives us 124 equals d. Definitely an easier problem than the last one, huh? No square roots there. So it's a 124 inches. And it's actually not about 124. It's exactly 124 because we cancel out the pi's as pi, not as a value of pi, which was done in the original problem without knowing. So again, here we got to estimate that. We would round this one. So this one, the diameter is 124. Again, ask questions, check your homework, and let me know what's going on. Thanks for letting me know about the pages being upside down. I'm working on that. I'm not very good at this stuff, but I'm trying to get things straightened out for you. Have a good one. Bye-bye.